While we're on the topic of use and understanding in regard to physics, and before we actually turn to some of the physics in the form of quanta and fields, I wanted to talk a bit about scientific realism. And for our listeners who aren't familiar with this debate, it's one of the biggest debates or topics in the philosophy of science. It's the question of whether we ought to be committed to the existence of the objects or structures postulated by our best scientific theories. And historically, I think, and maybe you can weigh in on this, but the strongest argument for having commitments of this sort goes back to Hilary Putnam and is called the no miracles argument. And it holds that it would have to be some sort of miracle for the predictions of, say, the standard model of particle physics to be observed to the degree of accuracy that they are, without the standard particle model being at least largely true. But then, on the other hand, the best argument against it is known as the pessimistic meta-induction, which holds that basically if all of our best theories have been false in the past and we've had to throw out those either object-based or structure-based ontologies, is it rational to have any credence that our current ontology is right? So in general, where do you see yourself in this debate as it relates to quantum mechanics, or maybe more particularly the standard model?
Well, I think that there's two separate questions. One is, within the way that we think about any one theory, does the best way of thinking about that theory hold that you should treat certain parts of it as real? In other words, specifically what I have in mind is, in quantum mechanics, do you treat the wave function as representing reality? Some versions of the foundations of quantum mechanics say yes, some say no. That's just purely within everyone agrees on quantum mechanics, right? But we're disagreeing with what parts of it are ontologically relevant. There's another question. I think it's a separate question to ask, okay, but you don't know that quantum mechanics is right? I mean, that's the question about meta-induction. And you might say, well, why bother thinking that wave functions are real if someday wave functions might disappear because quantum mechanics is no longer right? And for the latter question, I think that structural realism essentially solves it for me. The idea that what is real and what is not going to go away are certain patterns, certain structures in our theories that have been empirically verified. Newtonian mechanics has a different ontology than general relativity does. But apples still fall from trees in both Newtonian mechanics and general relativity. So it's okay to attribute some reality to that phenomenon, even though the ontological explanation for it is completely different in these two different theories. I don't think anyone should claim to know the final ontology of nature and only be realistic about that. That would be very, very hard to pull off. But you can think that there is something that is the final ontology, even though you don't know what it is. And these structures that emerge at higher levels are what we are learning about through scientific practice. Now, in the question of quantum mechanics itself and the wave function, I agree with Putnam. I mean, the wave function is super duper useful in quantum mechanics. We really can't do without either it or some equivalent of it. So, of course, I think it's just very natural to treat it as representing part of reality. And it's a short road from there to believing in the many worlds interpretation of quantum mechanics, but we can argue about that. But I'll point out that in the book, this came front and center, even though my goal was to only talk about things everyone agrees on. I had to talk about quantum mechanics, and not everyone agrees on quantum mechanics, even though they agree with the final predictions. But the way that you talk about it along the way can be very, very different from person to person. So I made an executive decision saying I'm going to talk about quantum mechanics as if the wave function is real. And if you don't like it, you can always translate it into your own way of thinking about it. But I can't, every time I try to say something about virtual particles, include 2 pages of disclaimers and caveats saying, well, different people will talk about them differently.